So first we solve the first problems. This problem is just Poisson distribution problems, and we can see the Poisson formula is just given in the questions. The first question is to find the lambda, and we can get the preconditions. It is the probability that in 2 minutes at least one customer arrives equals to 0.3, and from this we can get its opposite event is in 2 minutes no customer arrives equals to 0.7. So we can get this formula, this equation: 1 minus 0.0, 1 minus probability of 0 is equals to 0.3, and then we can get the lambda easily. The lambda is about 0.178 per minute. And the second question we can see is to find the probability that in 10 minutes at least 2 customers will arrive. And also we find its opposite event is in 10 minutes 1 customer or no customers will arrive. And so we can similarly get the similar equations to find out the probability. The probability is equal to 1 minus probability of 0 minus probability of 1. Also from the Poisson formula, we can get the probability is about 0.531. And we can find the third question. It is to let us to find the probability that in 1 minute exactly 1 customer will arrive. It is very easy. Just use the Poisson distributions formula. T equals to 1 and K also equals to 1. So we get the answer. The probability is about, the probability is about 0.149. And the third question is similar with the third questions. The first question is to find the probability that in 3 minutes no customer comes. That means the T equals to 3 and the K equals to 0. We can also use the Poisson's formula and get the probability is about 0.586. Okay, then we come to the second problems. And the second problems we are given by f of x. It is equal to 3 questions. First, we want to find a, so that f of x is a valid density. How to get a valid density? It means that It means that we integral fx from minus infinity to infinity, and the answer is just equal to 1. So we can get these equations: a times e2 minus 2 plus e2 minus 1 times e minus e2 minus 1 is just equals to 1. Through these equations, we get a is just also equals to 1. Then we need to sketch the fx, so we can see also fx is given in the following at about question 4. We can see when x equals to 0, fx is equal to e2 minus 2. It is about 0.13. Then when x is bigger than 0 and smaller than 1, it is a line between 1 and 0, and you can see just in the figure. And when x is bigger than 1 or smaller than 0, fx is just 0. So then we can get the figure at just as I draw on my paper. And the third question is to write fx in one line by using step functions. And we can see we use step functions at just as I write on the paper. It is equals to unit step functions of x minus unit step functions of x minus 1, and then time it to e2 minus 1 times e2x plus e2 minus x. And the first question is to find the capital F of y in an analytical form. First, we get the f of x, then we integrate it to get the capital F of x. What we want to mention is all of the integration will get a constant such as C1, C2, C3, and C4. So finally we get a capital F of x equals to, when x smaller than 0 is C1, when x equals to 0 is e2 minus 2 at C2. When x is between 0 and 1, it is just equal to e minus 1 times e to x minus e2 minus x at C3, and when x is just bigger than 1, it is equal to C4. Also, we know that the capital F of x is right continuous, and f capital of x, when x is equal to minus infinity, it is equal to 0, and when x is equal to plus infinity is just equal to 1. So we get C1 equals to 0 and C4 equals to 1. Okay, as we see, capital F of x is right continuous, so f when x is nearly to 0 from the right hand, and this is just equals to capital F of 0. So C3 is equal to e2 minus 2 plus C2. Also, we know f of x is smaller than 1 when x is nearly to 1 from the left hand. So we also get 1 minus e2 minus 2 at C3 is smaller than 1. So finally we get that C3 is smaller than e2 minus 2 and C2 is smaller than 0. All of this we can see at last C2 is between minus e2 minus 2 and 0. All of this is the region of C1, C2, C3, and C4. When you determine C1, C2, C3, and C4, then you can easily to draw the figure of f capital of x. Because there is also some questions about this constant, so I haven't drawn the pictures immediately. I want to ask these questions to my professor. Thank you very much. So